Next, we're looking for the tension in the chain. So, how does the chain related to other bodies in this problem? So this is the chain, and we can see that the chain is attached to the pulley. So the tension here is actually that the tension that the chain is acting on the pulley. So pulley is the body that we need to look in it in this question. So let's label it a the third body, the pulley. The pulley, as in the problem statement, said that is a very light one. So it means that the mass of the pulley can be negligible. There should no weight considered here. So we don't have weight 3 acting on the pulley here. But instead we should have the tension, right? Because here obviously the tension is the forces that acted upward, straight upward, that keep the pulley in space. So how can it stay still? It will need some other forces to balance it, right? To cancel out these chain. And naturally, just looking at any other object that in direct contact with the pulley, yes, we does have it here. That's the rubs here and this rubs here. Okay, so let's just have a more closer look into this section. We can see that the nature of the force that acting on the pulleys here is from the weight 1. So the rub here acting as a medium to enable the interactions between the weight 1 and the pulley. And here is also a really good question to help us to revise another law about forces, Newton's third law. Newton's third law states that every forces will exist in a pair of action and reactions, just as that when you hit something, is that something also that hits you at the same time. That's why you also feel hurt, right? And those pair of action and reaction, they would be opposite in direction. They act on different objects, okay? That's the most important thing. Just like here, T1 here is the pulley acting on the rod. So we are looking at this point. And the reaction will be the rod acting on the pulley. On the pulley here, that's what we need here. That's the F1 here. And magnitude, they are on the same. So this is a review about Newton's third law. Anyways, that helps us to identify that F1 magnitude should be the same like the tension as well as F2. And then we can see that the same thing in order for the pulley to stay in equilibrium at rest, no motion at all, then all the forces have to cancel out each other. We have these upward, we have this upward, we have these downward. So this means that the magnitude of the chain, the tension, should be equals to F1 and F2. And each F1 equal to the tension. That's what we found in here. That's why it